Hello friends, welcome to Live Here Do Mathematics. Today we are going to solve a problem from K Mapa's Abstract Algebra book, exercise 3, page 83 and question number 3. Okay, so the problem says a square matrix capital A is said to be a nilpotent matrix of order P if P is the least positive integer such that A power P equals to 0 matrix. Okay, so this is basically the definition of nilpotent matrix. Okay, now the problem says if A is an n by n nilpotent matrix of index 2, prove that both In minus A and In plus A are non-singular matrices. Here In denotes identity matrix of order n by n. Okay, so we have to show that In minus A and In plus A are both non-singular matrix. So a matrix, when we call a matrix non-singular, suppose A is a matrix. A is a matrix. Then A non-singular. So the matrix A is non-singular. So A is non-singular. That means det A not equals to 0. And this is vice versa. If det A not equals to 0, then A is non-singular, and A non-singular means det A not equals to 0. So basically we need to prove that det of In minus A not equals to 0 and det of In plus A not equals to 0. So to prove det of In minus A not equals to 0 and det of In plus A not equals to 0. So given that, what is given? What is our tool in here? Given that A is an n by n nilpotent matrix of index 2. So A is an nilpotent matrix of order 2. So what does this imply? This implies, so a nilpotent matrix of order P means A to the power P equals to 0 matrix. So a nilpotent matrix of order 2 means A power 2 equals to 0 matrix. Okay, so we have this A square equals to 0. Okay, so now we have to prove that det of In minus A not equals to 0 and det of In plus A not equals to 0. So to prove this, we need a result. So we will use this result. Det AB equals to det A times det B. So equivalently, if we don't write the det can be write by this sign also. So basically we have det AB equals to det A det B. Okay. So now we will use this result to prove the theorem. Now consider this. The product In minus A times In plus A. Consider the product of this matrix and then det. So consider In minus A as matrix X and In plus A as matrix Y. Then we have det of xy. This can be written as det of xy equals to det x, that is det In minus A times det In plus A. So det xy equals to det x, det y, that is det In minus A into In plus A equals to det of In minus A into In plus A. Okay, so we have used this result, det A equals to det A det B. Now we will consider this product. This product is In multiplied by In plus In multiplied by A minus A multiplied by In minus A times A. Okay, and then det of this. Now this is equals to In times In is In plus In times A is A minus A times In is minus A, and this is minus A square. Now plus A minus A cancels out, then we have In minus A square. Now again we have in our hand that A square is the 0 matrix. Then this det is equals to det In minus 0 matrix, and if we consider this, if we subtract the 0 matrix from any matrix, then we get that matrix, that is, this will be det In, and det In is 1, because this is the identity matrix. All the diagonal elements are 1 and all other elements are 0, so det will be 1. Okay, so we have now that det of In minus A times det of In plus A equals to 1. That is, we now have that det of In minus A times date of in plus a equals to 1. So the product, so date is basically a real number, so product of two real numbers, this is a real number and this is a real number, is equals to 1. So both of them are non-zero, because if one of them is not 0, then their product should be 0. So this implies that date of in minus a is non-zero and date of in plus a is non-zero. So we needed to prove this, that in minus a and in plus a were invertible as their date is non-singular. We needed to prove that in minus a and in plus a were non-singular. So as their date is non-zero, so they are non-singular matrices. So in minus a and in plus a both are non-singular matrices proved. So thank you friends for watching the video. Hope you have enjoyed the video. And if you like this video, please subscribe the channel and don't forget to share the video with your friends. Stay tuned with us because we will come back shortly with this kind of video again. Please share the video and don't forget to tap the bell icon, because we will come back again with this kind of video and you will get the notification of all your upcoming videos. Thank you.